So this is a video which serves as an introduction to statistics. For some of you, it may be all new. I hope that for many of my students, it will be a useful revision of some of what we've done previously in Barnwood Park. We're looking primarily at averages and the distribution or the variation or the spread of a range of numbers within a list. So there you've got some definitions: mode, mean, median, and range. And first of all, I want to find the mode from those numbers, 9, 6, and 9. Well, what number occurs the most? Obviously, it's going to be 9. But what about the mean? How do I find the mean? Well, it says there, I'm going to add all three together, and then I'm going to divide by 3 because there's 3 numbers. So I can see there 9 plus 6 plus 9 divided by 3 gives me a mean of 8. And then I want to find the median. Well, first thing I need to do with the median is I want to take my data, my values, and I want to order them. Normally we do it from lowest to highest, and then we're going to do that, and then we'll look at trying to find the middle value. So let me just rewrite those numbers. So now we have them 6, 9, and 9, and you can see that the middle value, the 9 in the middle, is my median, so therefore I'm going to write that as 9. And then the range, finally, well, the range is the difference between the largest and the lowest value. So there you can see I've written 9, take away 6, gives me a range of 3. So before we move on, very quickly, can I just stress that whatever average we use, whether it is the mode or the mean or the median, your value of that average needs to be somewhere between the lowest and the highest value in your list. If I worked out that my mode or my mean or my median was, say, 10, then I would know I'd made a calculation error, because 10 is outside of that range between 6 and 9. Has to be somewhere within those values. Let's move on and try a different set of numbers. On second thoughts, here's a little bit of an extension task. We talk about the mean, but actually we mean the arithmetic mean. You'll find in mathematics, when we talk about things mean arithmetic, often we're talking about adding and subtracting. You may have come across arithmetic sequences where maybe you add 3 to each term in the sequence. And so your arithmetic mean, which is what we normally use, 9 plus 6 plus 9, all divided by 3 gives me 8. But if you go on to look at statistics in year 10 or year 11, then you'll come across what's called a geometric mean. Well, we use geometric in terms of multiplying. So you might have come across a sequence which we call a geometric sequence, where perhaps things double. So you have 2, 4, 8, 16, 32. That type of sequence is written differently. And geometric means multiply. So again, instead of adding them, we go 9 times 6 times 9. But instead of taking the dividing by 3, we take the third root. If we had 4 numbers, we would multiply all 4 together and take the 4th root on your calculator. And again, notice both my arithmetic mean and my geometric mean, they have values between the lowest and the highest values in that list. And now we'll go on and get another example. So here's a set of 4 numbers in my list. So my mode, well, I look at those, and what do I have? Well, I notice that 8 appears twice, so 8 will be my mode. What about my mean? Well, again, I'm going to add them together, and this time, instead of dividing by 3, I'll divide by 4. And there you can see that when you add them together and divide by 4, you get a value of 6. And then the median. Well, to get my median, again, the first thing I have to do is put them in order. I don't just say, well, I have 2 and 8, so halfway between those is 5. I must put them in order first. So if I do that, I get this. And then from this, I can see that 2, 6, 8, 8, my median is going to be halfway between 6 and 8. There's like two central values, so halfway between 6 and 8. How do you find the halfway point? Well, you add them together, divide by 2. So 6 plus 8 would be 14. 14 divided by 2 is 7. And then finally my range, well, the biggest value, take away the smallest value. And there you go, the range is of course 6. So again, mode 8, mean 6, median 7, they happen all to be different values. Sometimes they're the same, but notice every one of those averages is between the lowest 2 and the highest 8. Let's move on. So this time I have some negative values in my list. So for my mode, I look there and I don't see any numbers that occur more than once. So I'm going to say my mode is there is no mode, and that can be a perfectly acceptable answer. My mean, I'm going to add them all together, but I need to take care with the fact that some of them are negative. So if I'm using my calculator, I'm going to enter those really carefully, making sure I use brackets on my calculator so that we don't in any way get ourselves confused. So there we go, and there are my values. And then I'm going to go on and look at my median and my range. Well, again, the median, I'm going to rewrite those numbers and put them in order. And having put them in order, knowing that -5 is the furthest left, then my median is going to be right in the middle, because there's 2 to the left and 2 to the right of the 3. So that's my median. And then my range, well, again, here, I need to be a little bit careful. It's going to be 11 take away -5. And it'd be very easy to write that as 11 take away 5, but actually it's 11 take away -5, and that comes to a range of 16. If you weren't sure about that, maybe you'd write it on a number line, and you can see there's 16 numbers between -5 and 11. So again, I'm going to just stress again, 4.4 and 3, both of those averages are between the -5, lowest, and the 11, highest. Always worth checking that. So let's move on to a far larger set of data values. 3, 1, 2, 1, 5, 13, 10, 6, 8, 5, 11, 12, 15, 8, and 5. Well, before we look at any of those averages, I'm going to start by ordering them, because it's very easy to get ourselves confused with so many numbers. So we'll take a few moments and put them in order. So now that they're in order, it becomes a lot easier to see the numbers I'm dealing with. So I look for my mode. How many do I have of each number? I notice I've got 3 lots of 5. That looks good. I've got 2 lots of 8. Is there anything else? I think that's it. So 5 should be my mode. What about my mean? Well, I'm going to add each one of them up. And actually, I find it easier to add them up when they are in order, so I know I'm not missing any or on my calculator. So there we have all of those numbers, and I worked out that again our mean is going to be 7. Now what about the median? Well, I can cross off 1 from each end and work my way through, and if I do that, I find this is my median. I've used a little bit of color there. You might want to maybe cross them off as you go along. But I can see there that 6 is in the middle of my data, that I have 7 numbers to the right and 7 numbers to the left. And therefore my median is going to be, very clearly, is going to be 6. And then the range, well, as before, 15 take away 1. And of course, that gives a range of 14. So mode 5, mean 7, median 6, each one of those between the lowest and the highest. And then the range gives us a feel of the distribution. We'll come on to that very soon. But there's more that we can do with this set of data. So I've written out the data again, ordered. We've already worked out that the mode is 5, mean is 7, median is 6, range is 14. We're going to introduce something called quartiles, lower and upper quartile, which is a bit like a second level of medians. I'm going to show you how we do that. So first of all, I know my median is 6 because that's halfway through the data. So I'm going to split my data like this from 1, 1, 2, 3, 5, 5, 5, and 6, and look at that, and I'm going to say to myself, where is the middle number in that? Well, if I look at 3, I can see that there are 3 numbers to the left of 3, and there are 3 numbers to the right of 3 before we get to our median. And this gives me the lower quartile. It's like I'm taking these numbers here and I am finding the middle of those. So I'm going to write in my lower quartile is 3. And then I'm going to do the same thing over here. I'm going to look at those numbers there, 8, 8, 10, 11, 12, 13, and 15. And what number there is in the middle? Well, I can see that 11 is, because I have 3 numbers between 11 and the median and 3 numbers to the right. And so my upper quartile is 11. And therefore, my interquartile range, well, that's again maybe new to some people, similar as range is maximum take away minimum, or highest value minus lowest value. We do the upper quartile, 11, take away the lower quartile, 3, and that gives me an interquartile range of 8. I'm going to look at why you might use that. So we've introduced concepts of lower quartile, upper quartile, and interquartile range. So here's our set of values for that data again. I've highlighted those values. I've written minimum 1, lower quartile 3, median 6, upper quartile 11, and maximum 15. One of the things we do in our GCSE studies is we learn to represent this using a special chart. We call it a box plot, sometimes call it a box and whisker plot. And I'm going to show you one of those just now. And here you can see my box plot, and you can see that the minimum is the extreme line, the maximum is the other line there, the other extreme, and then we have our lower and upper quartiles represented in median at 6 there in the middle. And that's a really interesting way of showing how spread out the data is. And again, MathsWatch will look at that in much more detail. I want to finish by looking at a problem that we have with averages and helping us to understand why some averages are more suitable than others. So I want you to imagine that these numbers represent something. Let's say that there is a number of football matches taking place during in an area on a Saturday. And this is the number of goals that the winning team scored. So 2 teams scored 2 goals, 1 team scored 3 goals, 2 scored 5, 1 each scored 6 and 8. And then there must have been perhaps a very weak side because 1 team managed to score 25 goals. Now you might notice that that is quite an extreme value. It's quite different from all of the other values. It's lying out there at an extreme, and we call that an outlier because it lies out of what we'd expect to see as normal. And I want you to see what happens when we do our calculations. Now, the mean, first of all, I add them all together and I get this. Now, 7 is over here. It's sort of halfway between the 6 and the 8. And to say the average number of goals scored is 7, well, mathematically it's true, but actually most of the teams, 6 of the games scored less than, and only 2 scored more than the average. So the mean seems to be affected by that funny 25. If we were to find the median, well, it's going to be between 5 and 5 because there's 3 to the left and 3 to the right. So my median will be 5. And if I was looking for an assessment that said, on average, how many goals were scored, I would say 5, yep, looks about right. What about the range? Well, again, we have 25 take away 2, and that gives me a very large range of 23 goals from the most scoring to the least scoring. And then the lower quartile. Well, that's an interesting one to find. My median is here. Now, strictly speaking, my median is between the two 5s. So to find the lower quartile, I'm going to include the left-hand side of the 5. So I'm going to be looking at these 4 numbers. And so 2, 2, 3, and 5. The middle position here will be 2.5. Now, actually, there are other ways of working this out, and you'll look at that later on in statistics. But for now, this is a good rough and ready way of doing it. And the upper quartile, I'm going to look at these 4 numbers, and the middle one there between the 6 and the 8. Well, that should give me an upper quartile of 7. And then my interquartile range works out at 4.5. So when I look at those, it seems to me that the median is a better average. But what about the distribution in goals? How much variation was there between the games? Well, 23 is accurate in terms of the range, but actually 4.5 is perhaps a more reasonable measure of how much variation was going on there. So some got 2, some got 6. 4.5 is more of a reasonable value. We're going to look at that just as we finish. So here we've got exactly the same set of information. The ranges are there, the averages are there. So let me read to you. When analyzing a set of values, or set of data values, we need to consider 2 things. 1, the average value, and 2, the overall distribution of those values. Are they close together or are they widely spread out? So there are different ways of doing this. Now, one way is in terms of average, we use either the mean or the median. And the mean can be a very good average. It takes into account all of the numbers on the list. But if one of those numbers is extreme, like really, really high, it tends to skew or to affect the mean. The median, on the other hand, ignores that really, really high value. If that really high value had been 8 instead of 25, the median would still be the same value. So the median does give us the middle number, and that can be really useful, but it doesn't actually take into consideration all of the values in our list. So there's pros and cons to both of them. The range, in terms of how spread out is our data, the range is very easy to calculate, but if one of those 2 extreme values is really big or really small, then again it skews that sense of distribution. In real life, most of the goals were around about 4, 3, 6. They were quite close together. It's just that one extreme skewed the values. And the interquartile range is perhaps quite complicated to work out. You've got to find the upper quartile and the lower quartile, but nevertheless 4.5 shows me the spread, the distribution, because it only looks at the central 50% of those values. So if you go on to do maths at a higher level, or you go on to do statistics, then we're going to be able to look at that in more detail and show advantages and disadvantages. But when we are doing our GCSE papers, and you're given, say, a box plot or something like that, or maybe a frequency polygon, and you're asked to compare to, then you'll be asked to compare the average, and you'll be asked to compare the distribution. So try to remember those two. Well, thank you for watching this very brief overview. I hope for those of you who've done stats before, it was helpful. For those of you who haven't done very much, it's an introduction. So the plan is, as you now look through your Maths Watch videos, I'm hoping it'll make a little bit more sense. As always, feedback's appreciated. Drop us a line, and thanks for listening.